this brief video, we'll learn how to simplify a common sort of product that we encounter in geometric algebra. And here I've illustrated it in the three-dimensional case. E1, E2, and E3 are a set of mutually perpendicular unit vectors, or in other words, an orthonormal right-handed basis for three-dimensional geometric algebra. Let's take a look first of all at some of the properties of the products of these vectors. The product of any one of them with itself is 1. The product of any two of them is equal to their dot product plus their outer product, and because these vectors are perpendicular to each other, the dot product is 0. So EI EJ is EI wedge EJ. And also, if we reverse the order here, EJ EI is EJ wedge EI, which is the negative of EI wedge EJ, giving negative EI EJ. So this is an important property that we'll make use of many times in geometric algebra. If we reverse the order of these basis vectors in the product, we will reverse the sign of the product. Also, geometric algebra is an associative algebra, so geometric algebra products possess the associative property, and that's the first property we'll make use of in our simplification. So we'll associate E1 and E2, then reverse their order to get negative E2, E1. Next, we'll associate the E2s to get the negative of E2 with itself, giving negative 1. Now we'll associate E1 and E3 and reverse their order, so we change the sign. So we'll end up with E2, E1, E2, E3 gives E3, E1. And many of you probably realized from the outset what's going on here, because our original product is E2 times the unit trivector for three-dimensional geometric algebra, and E3, E1 is the unit bivector to which E2 is perpendicular. So this is an example of an important fact in three-dimensional geometric algebra. If we multiply any unit vector by the unit trivector, we get the unit bivector to which the original vector here is perpendicular, and of course it's in the right-hand sense. So I hope this video has been useful, and I hope you'll consider joining the LinkedIn group Pre-University Geometric Algebra, and I'll post the link in the video description. Thank you for your time.